All right, today we're jumping into a scenario that is pure, uncut science fiction. We're talking about breaking not one, but two of the universe's most unbreakable rules, going faster than the speed of light and escaping the pull of a black hole. This is the ultimate cosmic jailbreak. But could it actually happen?
So let's just get right to it. This is the big question. It's an incredible thought experiment that pits two cosmic titans against each other. On one side, a hypothetical ship that can travel faster than light, or FTL. And on the other, the most extreme, most powerful object in the entire universe, a black hole. You know, the answer here isn't a simple yes or no. It actually peels back the curtain on some of the deepest and, frankly, weirdest truths about the fabric of reality itself.
So here's our game plan. First, we're going to tackle the whole idea of FTL travel, because it's got some major issues. Then, we'll dive into the truly bizarre physics inside a black hole. After that, we'll smash those two ideas together to get our final verdict. And stick around, because at the end, we'll peek at some wild theories, like quantum gravity, to see if they offer any loopholes.
Okay, so before our ship even gets near a black hole, we smack right into our first giant wall. The problem with going faster than light isn't just about building a better engine. Oh no, it's way, way deeper than that. It breaks the single most important rule in the universe, cause and effect.
To even try and wrap their heads around FTL, physicists came up with this purely theoretical particle called a tachyon. Now the idea is wild. Tachyons have to travel faster than light. They can never ever slow down to light speed. But for any of the math to work, they need to have something called an imaginary mass, which is a concept that, well, when you square it, you get a negative number. Yeah, it's already getting weird.
And this really gets to the core of the issue. See, for anything made of normal matter, like you, me, and our spaceship, hitting light speed would take an infinite amount of energy. It's impossible. Tachyons cleverly get around this by always being faster than light. But the price they pay is that imaginary mass. And physicists think that if these things actually existed, they would trigger a catastrophic instability in space itself, a process with the awesome name of tachyon condensation. Basically, the universe as we know it would just unravel. But let's pretend for a second. Let's say we could somehow make a stable universe with tachyons in it. We'd still face an even bigger, more brain-breaking problem. The real deal breaker for FTL isn't the speed or the energy, it's time. It's that sacred, unbreakable law that an effect can't happen before its cause. And this brings us to one of my favorite thought experiments, the tachyonic antitelephone. So picture this. You send a message faster than light to a friend on a distant ship. Because of the wacky rules of special relativity, that message might look like it's going backward in time to them. They could then immediately send an FTL reply back to you, a reply that arrives before you even sent your first message. You would get the answer to a question you haven't asked yet. It makes a complete mess of logic. Causality is just shattered.
Okay, so FTL is basically a logical nightmare. But hey, let's be generous. Let's say we built our paradox-creating ship anyway, and we flew it straight past a black hole's event horizon. We're inside. Now we're facing a whole new kind of prison. This one isn't made of gravity. It's made from space-time itself.
This one idea, right here, from general relativity, is one of the most mind-bending concepts in all of science, and it is the absolute key to this entire puzzle. The moment you cross that point of no return, the event horizon, the very meaning of space and time as you understand them just gets thrown out the window.
This table breaks down that cosmic switcheroo perfectly. Out here, where we are, space is about direction. You can go up, down, left, right, you have choices. Time, on the other hand, is like a river. It only flows one way, forward. But inside the event horizon, that completely flips. The spatial direction toward the singularity, toward the center, stops being a place. It becomes the flow of time itself. It becomes your future.
So this is the big takeaway. Trying to use your FTL ship to fly away from the singularity is like trying to use a sports car to avoid next Tuesday. It just doesn't make sense. It doesn't matter how fast you go or which way you point your ship. The singularity is no longer a physical place you can steer away from. It's a moment in time you are absolutely 100% going to experience. All roads, all futures, they all lead to that one point.
So now we can finally bring our two huge barriers together. We've got a ship that fundamentally breaks the laws of logic, and it's stuck inside a prison that has literally turned space into time. When you put those two together, you get a very clear, very loud answer.
The verdict is a double impossibility. It's a no on two different levels of physics. First, from special relativity, the FTL ship itself probably can't exist without destroying cause and effect. And second, even if it could, general relativity tells us that once you're inside the black hole, there's no direction called out anymore. The only direction is forward in time, and that direction ends at the singularity. You literally cannot escape your own future.
You know, it really seems like the universe has its own kind of firewall to protect itself from these kinds of paradoxes. It's called the cosmic censorship hypothesis, and it basically suggests that nature will always hide a singularity, this point where our physics just breaks, behind an event horizon. That horizon acts like a cosmic one-way door, preventing all that chaotic, causality-breaking weirdness from ever leaking out into the rest of the universe.
Now, everything we've just talked about is based on Einstein's theories of relativity, and they are our absolute best description of how gravity and space-time work. But they aren't the final word. Right at the very heart of a black hole, our physics breaks down, and we know we need a new theory, a theory of quantum gravity, to really get what's going on.
So, does that open up a potential loophole? Could quantum mechanics give us some secret backdoor that Einstein's theories just didn't account for? Well, the ideas here are highly speculative, but they do offer some pretty fascinating alternatives to the classic picture of what's inside a black hole.
One of the leading ideas is something called loop quantum gravity, or LQG. What this theory suggests is that you never actually hit that infinitely dense singularity. Instead, quantum pressure kicks in and stops the collapse. The black hole might then bounce and transform into a white hole that spits everything back out. But even in this wild scenario, the journey is still a one-way trip through time. The destination might have changed, but you're still locked onto that same unchangeable path.
And of course, we have to talk about the other classic sci-fi escape plan, the wormhole. In theory, yeah, a wormhole could link the inside of a black hole to somewhere else entirely. But to keep a wormhole open, you'd need huge amounts of something called exotic matter, which has negative energy. We've never seen it, and we have no idea if it can even exist. And even if it could, physics seems to put strict rules on wormholes to stop them from becoming time machines. The universe really does not like paradoxes.
So, after this whole journey through imaginary particles, broken logic, and twisted up spacetime, it's time to bring it all home and give the final word, based on everything we currently understand about physics.
No matter how you slice it, the answer from physics is a clear and resounding no. Special relativity tells us FTL travel is a no-go because it breaks causality. General relativity tells us escape is impossible because it rewrites the rules of space and time. And the universe's most fundamental structure, the fact that you can't outrun your own future, is the ultimate lockdown.
But here's the cool part. While the escape hatch from a black hole seems firmly shut, this whole thought experiment blows the doors wide open to some of the biggest mysteries in all of science. Why does time have an arrow that only points forward? What actually happens to all the information that falls into a black hole? And what really goes on at the very center, where relativity and quantum mechanics have to finally shake hands? Answering those questions, that's the next great adventure. And it all starts by asking, what if?